It's my pleasure to chair today's session. 很高兴能够在这里主持今天的我们这个会议的这个技术讨论。那么现在下面一个presenter 是 Cleveland 的陈。那 Cleveland 呢他的机械专业毕业，然后中国人民大学的硕士学位，他已经有17年的在这个TestConX这个行业里面的经验。目前他担任史密斯 Interconnect 研发部的经理。下面我们请 Cleveland 介绍他的 presentation。谢谢。
Thank you so much for the introduction, Frank. Good morning, good afternoon, good evening, everyone. Today, the topic that I'd like to present is regarding the coaxial structure application on macro pitch sockets. To cater for the rising common concern of the fine pitch, high-speed device testing in semi-test industry. About the main contents, I will introduce the background and cover the non-coaxial solutions for fine pitch device high-speed test. Then, the main challenges of the coaxial structure applied on the fine pitch socket will be discussed. After that, I will present the Smith Interconnect approaches a new product named DaVinci Micro. I will introduce the main features, technical highlights, structures, etc. And the internal lab evaluation result and the real application socket test performance will also be shared. And finally, the summary section. What are the main reasons driving us to have this topic? First reason is the marketing needs. Like most of us, consumers keen to be connected, able to access the digital world always. To meet this marketing, mobile device such as cell phones, tablets, and car infotainment with sophisticated system on chips ever produced. Those chips with increased function usually combine different function modules like CPU, GPU, AI agent, camera processor, etc. in a smallest possible form factor. It means a small chip size and the bore and pad pitch is usually less than 500 microns. Second reason is high-speed chip technology trends. The functionality increased chips sending and receiving largest amount of data with the lowest latency over the air. And the chip size reduction leaves the critical high-speed signal lines susceptible to noise and crosstalk, cause false failures during test. This results in the strict signal integrity performance application requirement criteria for this kind of device testing. Third reason is the existing high-speed test socket. There is some application limitations on the mechanical structure and electrical performance. I will share more in next 2 slides for this one. So about these 3 reasons drives the development of fine pitch coaxial structure socket. Okay, current common non-coaxial solutions for fine pitch high-speed device testing. Most of them seeking short electrical transmission paths to meet application, to meet the suitable signal integrity performance. One approach is using normal plastic socket with a shorter spring probe. As you may notice, the pin working length reduced from about 6 millimeters to about 1 millimeters over the last 15 years. But due to the manufacturing capability and application reasons, there is a constraint for short spring probe length. The limitation for this approach, like the limited compliance, spring probe force not sufficient for some applications, RF performance may not good enough for some the strict high signal integrity requirement projects. Another idea is using a conductive elastomer socket. This is also intended to get a short electrical transmission path. Due to the elastomer material property and the conductive particle column, the working mechanism, there is a special product property for this product, like the limited compliance, the individual conductive column force is relatively high, and like others, like the life maintainability, RF performance also need to be considered if we use it for real application. Applying the coaxial structure on fine pitch test socket, it is easier said than done. Compared to normal coaxial structure socket, we can find the fine pitch cost the limited room is a major challenge. It affecting the coaxial structure, cavity, and the spring probe design. How to make full use of the limited room to deploy signal pin, design proper corresponding cavity structure to meet target impedance is very critical. The major challenge of applying coaxial structure on fine pitch socket is balance the design and the manufacturing capability, ensure the complete the product with consistent manufacturing quality, especially for the signal spring probe strengths, and to meet the ultimate the target of meeting test stability and reliability is also actually very challenging. So how to ensure the final product with reliable, stable test performance? Actually, on product development stage, the application test stability and reliability, the requirement is the start point. It drives the desired the product property, like special features, strengths. Then those socket property that we want to have drive the technical requirements for the design and the manufacturing. For design, like the coaxial structure, fine pitch, the pin, cavity. For the manufacturing quality, like the pin components and the housing parts manufacturing, machining, and the spring probe and the final assembly and capabilities. During design stage, the design need align and balance with manufacturing capability always. On one hand, the design need to take the manufacturing capability into account, ensure manufacturing feasibility, yield, and cost. But on other hand, the manufacturing capability also should be fully developed to meet key design intention and realize the some challenging feature manufacturing feasibilities. So look at in the other way, actually the detailed design and the good manufacturing quality both determine the final product property and affecting the real application and test performance. So actually this is a two-way interaction process. Smith Interconnect overcome above those challenges, successfully developed the coaxial structure on fine pitch device test socket, named DaVinci Micro, a new series high-speed test socket specifically for a fine pitch device test application. It is a proper solution for BGA, LGA, QFN types of device testing. The mechanical specification it is can be used for 0.35 pitch above. The pin test length about 2.85 millimeter, 0.4 millimeter spring probe compliance. Pin force is about 10 for singular pin, 16 grams for the power ground pin. And the impedance is controllable. We can we have the custom specific design for 40, 45, and 50 ohms. And operating temperature is minus 40 Celsius to 125 Celsius degrees. For the electrical specifications, I will show the details actually on the labor evaluation result portion. But here I'd like to highlight one item. Here is the pin-to-pin noise reduction. Just as I mentioned, the increased function of the chips that makes the effect of pin-to-pin crosstalk worse during a test. But our DaVinci Micro socket fully shared the signal path, elevated the effects of crosstalk dramatically. So it is showing with immediately yield improvement compared with the non-coaxial socket products. For our DaVinci Micro main structure, you can see in this picture, it consists of spring probe, housing parts, a cartridge top and bottom, and the packed align part, align frame. You can see the structure is simple. The socket design can match existing PCB sort of socket footprint and test the hardware interface easily. So it can save the cost for the end user and the customer. And we have used two types probes. For the signal pin, we use one pin for the signal, another pin for the power and the ground. The DaVinci signal pin matches the system impedance is key for the socket performance. For the socket features, due to the just as I mentioned, this is as you know, this is a fine pitch application plus the coaxial structure. The spring probe strength is one of the key concerns for this DaVinci Micro product, especially for this signal probe. For this signal probe, the diameter is only about 3 human hairs, so it is very small. So how to ensure the pin with reasonable strength for the high volume device production test. So we have the special features like designed with a double moving structure, select the high rigid, high strength material, optimize the assembly process, installed it with plastic ring, etc. Regarding the test stability and reliability, and we also have some the special concepts to improve it, like the you can see a picture here. We call it high-low configuration. You can see the stronger power ground pin set higher than the signal probe. It means that the package will touch the stronger pin first. It can ensure the less impact to the signal pin. Another idea is using the floating base concept. The package will touch the floating base first, reduce the impact force applied to the all the pins. Can protect all the pins. And the idea is the special property insulated metal material we used. This material is very rigid, can make body deflection lower than all the pin with reasonable payload to keep the good connect to the PCB board. And this one I will share the more data later. And for this material, it also acting as a heat dissipator to transfer the heat, avoid the pin overheating issue. So all these ideas can ensure the good test reliability and stability to ensure our DaVinci Micro socket has a good performance, even for high volume production test. Next few slides regarding of our internal lab evaluation result. I will show the mechanical pin-related performance and the socket RF performance. For the mechanical perspective, a comparison research performed based on the same application. For this one, like pin count 3,600.35 pitch. You can see this the maximum deflation for the short pin and the DaVinci Micro pin. Our DaVinci Micro showing with less the deflection. So it means the DaVinci Micro socket can ensure the better the connector for the pin, for all the pin bottom tip to the PCB pad. For the pin, for the spring probe, the electrical performance, FDR, force deformation resistance. You can see from this chart, both of the chart, the single spring probe average series is about 100 or 106 milliohms. Test force 10.8 grams. For the power ground pin, average series about 46 milliohms. Force is about 20 grams. It meets our design actually intention. For the live performance, we can see from the both of this chart, the series of these two pins along the whole pin life of 500K is really quite stable. For the current carry capability testing, you can see from both of the charts, the signal probe is about 1.25 amps at the temperature rise 86 degrees. For power ground pin is about 1.9 amps. For the RF performance, single end 8A versus 2A. This is actual the measurement result. We didn't show the simulation result because the simulation result is very perfect. So you can see from this the measurement the result chart. You can see the for the insertion loss is about 31.5 gigahertz at minus 1 dB, and the return loss about 40 gigahertz at minus 10 dB. This is this table shows the 8A the pattern data result. For the differential pair, insertion loss and return loss, here we just showing the simulation result 2A pattern. The insertion loss higher than 40 gigahertz at minus 1 dB. Return loss higher than 40 gigahertz at minus 10 dB. So it is showing with a quite ideal the insertion and return loss performance. The actual measurement we are still ongoing, so no data showing here. For the differential pair crosstalk performance, we did a comparison research, compare the DaVinci Micro with shorter probe plastic socket. This is a simulation comparison based on 210A pattern, 0.35 pitch. For DaVinci Micro, we can see the near end crosstalk worst performance in the DC to 40 gigahertz is minus 59.5 dB. Far end crosstalk worst performance in the range is minus 58.7 dB. So you can see from this table and these two charts, our DaVinci Micro performance is much better, especially for the near end crosstalk performance. Performance comparison for the fine pitch high speed device test sockets between the normal socket with shorter probes, conductive elastomer, and the DaVinci Micro. So we can see the DaVinci Micro socket has overall excellent performance from the pin spring proper compliance, test force, application range, and RF performance, and maintainability, life, etc. For the DaVinci Micro actual performance in customer side, this is just one of the example. The target impedance is 45 ohms. This is the pattern that we did the simulation, get the result here. The pink color is pink position is signal pin, green is ground pin. So and these two pairs differential are researched. We researched, and this is the signal under two pins. So yeah. So this actually you can see this table. The DaVinci Micro the socket performance from the insertion loss, insertion loss, crosstalk, showing very good performance data. Okay, so we can see our coaxial structure socket at DaVinci Micro successfully developed applied on the customer side have very good performance. This is showing the socket DaVinci Micro, the DaVinci Micro socket properties. I don't want to repeat it here. The DaVinci Micro socket, just as I showed the example in previous slide, the product actually already shipped out to customer with high volume order. Tested at the customer side more than 4 months. I got a really positive feedback from customer. So DaVinci socket test stability, reliability, performance is proved by the real application. So the socket is successfully developed for fine pitch application, meet the market technical trends and the customer needs. Okay, that's all for my presentation. Thank you for your time, for your listening. Back to you, Frank.
Okay. Thanks, Cleveland. Thanks for your presentation. Let me see if any of the question come from audience. 大家有什么问题吗？你们有问题可以在那个 Q&A 上面可以送出你们的问题。OK， 先问第一个问题，就是DaVinci Socket， 你刚才介绍了它的一些性能，能讲一讲在现场怎么样做 maintenance？
Oh, thanks for the question. The maintenance of the DaVinci Micro is similar to other Smith Interconnect DaVinci product, like the pin replacement, clean. Actually, even same as the plastic, the spring prop socket. If we're using our custom manufacturing the fixtures, it is very easy to do the pin replacement, cleaning, and so on. So, yeah, actually the maintenance work is easier and even can error proofing if we're using our pin replacement fixtures.
Okay. Next question is you talk about the DaVinci product. How about the DaVinci Micro? Because you mentioned that it's the micro. How about this micro DaVinci Micro versus the other DaVinci product?
Okay. The DaVinci Micro product are mainly for the fine pitch high-speed device testing, like the sophisticated the SoC chips for 5G communication, computing, consumer and automobile market, etc. The DaVinci Micro socket, the pin housing cartridge top and the bottom actually manufactured from the Smith Interconnect property insulated metal material. It shares those critical signals throughout the interface, just as I shared in the presentation. Actually, it can significantly improve the crosstalk performance. And for the DaVinci Micro correct structure, intend to match the system impedance by the custom the cavity and pin size, providing a good, really ideal solution to improve the socket hole performance.
Okay.
And
audience.
Yeah.
Go ahead.
I mean our other DaVinci the product line is mainly for the bore pad pitch bigger than the 0.65 millimeter. So our DaVinci Micro is specifically for the bore pad pitch less than from 0.35 to 0.5 pitch.
Okay. One question from the audience is for DaVinci Micro socket, it means the socket material is conductive, but you have the insulation at the pinhole the wall, and then pin can contact with socket the body. Is that correct? So
yes, actually different pin. Yeah, actually different pin have different function, and they have different technical requirement for the surface. This is actually the know-how for the socket.
Okay. Another question is your force is only about 10 to 11 grams. Is there any issue about is there any contact issues? Seems like the force is very low.
Per our internal evaluation result and the actual test the feedback from customer for the power, ground, and the signal pin, the performance is very improved actually. For some application, I think for most of the application, even the 10 grams, I think is suitable for most of applications. I understand that your some of the concerns, but due to the size constraints, so the 10 grams is also not a good not an easy target. It's not an easy task to have this force level pin, because the size, as I mentioned, is only about 3 human hairs diameter.
Okay, thank you, Kevin. Thanks for the presentation. I think we have the time have to go to the next one. So Cleveland, thank you again. Okay, thanks.
And let me, okay.
By the way, the audience and really hope you can mark up your comments, send your in your score on the table we show on the screen. Okay, so thank you, Cleveland.